Good morning, kiddos. Welcome back. We are going to talk about 5.2 today, which is about congruent polygons. In specific here, we're focusing on triangles, but we will cover other polygons like this quadrilateral. Okay, so in chapter 4, we talked about something called rigid motion when we talked about rotation, reflection, and translations. Now, rigid motion is when we take a figure and we move it in some way, like a translation or a slide, a rotation, or a reflection, or like a flip. And it would not change the angle measures, and it would not change the segment lengths. Okay, when we talked about that, we found our congruent angles, or we found our congruent figures, and then our corresponding angles and our corresponding sides. So sides that go together after we have done some type of transformation. Okay, so right now we are going to look at this first figure, and we see that we have two triangles, and it looks like we have rotated it so that now point A is point D. The side with one tick mark is now above. The side with two tick marks is now below. Okay, so we are looking for our corresponding angles. Okay, so we are going to look for any angles that have any strike marks or those semicircles. And we can see that both sides of angle C have those angles. And we know that angle C on the left side is congruent to angle C on the right side because they are intersecting lines. And angles on opposite sides of intersecting lines are vertical angles and are always congruent. So we can say that angle, side, vertex, side. So I went through the two tick marks to the angle through the one tick mark. So ACB is congruent. Remember, that's an equal sign with a little squiggly on top. To angle ECD, side, vertex, side. Two ticks, strike, one tick. Okay, so I'm going in the same direction as the other one. So ECD. Now we are going to name our corresponding sides. So those are notated with those tick marks. So we know that B to C has one tick mark, and that is congruent from C to D, which also has one tick mark. So we will say it like this. BC with a line over top because it's a segment is congruent to CD. Okay, and then we also have A to C with our two tick marks and C to E with our two tick marks. So comma, and then AC is congruent to CE. Okay, and then when it asks for congruent figures, all we have to do here is pick a point and then go around the shape. So I'm going to start at point B, and the reason why I'm going to start at point B is so we can go again through our first tick mark to our middle angle, through our second tick mark, or two tick marks, to our third angle. Okay, so I'm going to name the shape BCA is congruent to, and then here we're going to name it in the same way. So through the first tick mark to the strike, and then through the second tick mark. So that is DCE. All right, so that's our first figure. I know that this is right on the edge at the bottom of the camera. Okay, so let's move on to our second figure, and then we can go on to giving these actual values when we compare them. Okay, so our corresponding angles are just any angles that have the same number of strikes. So we can see that angle J and angle N both have two strikes or two semicircles in there. So we can say that angle J is congruent to angle N. And the reason why I can just say J and N is because they are only referring to these two angles, okay? Whereas C could be referring to either side of this, or even these two outer angles that were not explicitly stated. Okay, we can also say K and M, okay, or Q and P. So I'm going to write those down as well. So angle M is congruent to angle K, and that angle Q is congruent to angle P. Okay. And then now we are going to take a look at our last angle here, angle L, which again, there's no mark saying this, but we know that this side of angle L is congruent to this side of angle L because they are on opposite sides of intersecting lines or they are vertical angles. So we know that these are the same. I'm putting 3 strikes on them so they're not similar to any of the other ones. And we have to name these with our side vertex side because angle L refers to all 4 of these angles. So we have angle, I'll go Q, L, K. Q, L, K is congruent to, and then I'll just go the exact same way here. So P, L, M. Now we can move on to corresponding sides. So we have 2 with tick marks and we have 2 with 2 tick marks. All right, so I'm just going to say that this is a reflection that we took this shape and we flipped it over this point L. So J to K matches up with M to N. Okay, so our first corresponding side, I'm going to write that. J, K is congruent to M, N. And then we have our bottom here, so JQ to PN. And then we have our 2 tick marks here, so KL and ML. KL is congruent to ML. And then our last one, QL and PL. Okay, and then like I said, the last thing we have to do is just name our congruent figures. So pick one and then go around the shape. I'm going to start with our tail, J, and then go up to K, down to L, down to Q. Okay, so we started our tail, up to M, down to L, down to P. So our congruent figures is going to be J, K, L, Q is congruent to N, M, L, P. It is important that you name them in the same direction. Okay, let's do an example where we're actually mapping angle degrees and segment lengths to another figure. Okay, so we have 2 figures. We have this XYZ and this MNL, and we are going to answer these questions. Okay, so the first question is asking us to find the measure of angle Y. So we are looking at angle Y, and we can see that that is the biggest angle in our shape XYZ. Okay, so we are looking for the biggest angle in our other shape, MNL. Okay, we can see that that is angle N, which is 124, making angle Y also 124 degrees. The second question is asking us what angle M is. Now, angle M is the smallest angle in this top shape, okay? So we are going to look for the smallest angle in our shape XYZ, and we can see that that is angle X, which is 33 degrees. So that means that angle M is also 33 degrees. Okay, I'm gonna write these in as well up here. To answer this next question, which is what is angle Z, which is our middle angle. It's not the biggest, it's not the smallest, which would correspond with angle L, which is also not filled in. So we are going to have to use one of our theorems that we talked about yesterday, which is the triangle sum theorem. And the triangle sum theorem says that when we add all of our angles inside the triangle together, we get 180 degrees. So we are going to take this shape, XYZ, and we are going to add 33 plus 24 plus whatever angle Z is equal to 180, and then solve for angle Z. So we have 124 plus 33, it plus the measure of angle Z, which we don't know, is equal to 180 degrees. So the first thing we're going to do is we are going to combine our 2 constant terms, or the terms without any letters. So 124 plus 33 is going to give us 157 plus the measure of angle Z, we still don't know what that is, so I'm going to leave it like that, is equal to 180. Now to get the measure of angle Z all by itself, we are going to have to do the opposite operation to this positive 157, which would be to subtract 157 once from each side of the equal sign. Positive 157 minus 157, those are going to cancel, leaving us with just the measure of angle Z. And then 180 minus 57 is going to give us 23 degrees. So that means the measure of angle Z is equal to 23 degrees. We'll write that in here as well. And then since it corresponds to angle L, I'll put that in there as well. Okay, and then our final task is to find X to Y, this segment length. Okay, and that goes from our smallest angle to our largest angle. So we are going to look at our second triangle and look from our smallest angle to our largest angle, and we can see that that is 8. Making X to Y also 8. All right, in this example here, our job is to find Y and X. So we are given this shape EFGH and these two angles. One of them says 4y minus 4 and one of them says 10x plus 65. Okay, so we are going to use this first shape ABCD and find these angles. All right, so we can see that angle A is our smallest and our pointiest angle. It is right above right over from the right angle, which corresponds to angle E, which is again the pointiest and the smallest angle and right above the right angle. Okay, so we can set up an equation here for our Y, which is that angle E is equal to 4y minus 4 and angle A is equal to 28. So from here, we'll just solve this like an algebra 1 equation. We will do the opposite operation to get our variable all by itself. So since we are subtracting 4, we will have to add 4 once on each side of the equal sign. Negative 4 plus 4, those are going to cancel because they add to 0, leaving us with 4 times y. And then 28 plus 4 is 32. All right, so now we are multiplying 4 and y together. So to get rid of the multiplication, we are going to have to divide by 4 once on each side of the equal sign. Multiply by 4, divide by 4, those are going to cancel because they go to 1, leaving us with just a positive 1y that we don't have to write the 1 for. And 32 divided by 4 is 8. So in this equation, y is equal to 8. Now we're going to do the same thing to solve for x. We can see that our x is 10x plus 65, and that is on our biggest angle. It's kind of the pointy one, which is our angle B, 135 degrees. So we're going to set this equation up as well. So we have 10 times x plus 65 is equal to 135. All right, same thing here. What we're going to do is we are going to start by subtracting 65 once on each side of the equal sign. Positive 65 minus 65, those are going to cancel because they add to 0, leaving us with just a positive 10x. And then 135 minus 65 is going to give us 70. Okay, so, and then since we are multiplying by 10, to get rid of that, we are going to have to do our opposite operation of division, once on each side of the equal sign. Multiply by 10, divide by 10, those are going to cancel because they go to 1, leaving us with a positive 1x that we don't have to write the 1 for. And then 7 divided by 10, or 7d divided by 10 is 7. So we found our x and our y. All right, in this last example, we are trying to find the measure of angle x, or angle 1 here. Okay, so we are going to use this triangle of MNL to help us find the angle 1 in triangle XYZ. Okay, so we can see that angle N corresponds to angle Y because they're both right angles. We can see that angle M corresponds with angle X because they're both the far off and pointy ones. And we can see that angle L and angle Z correspond, not only because they're the only angles left, but because they have these strike marks. Okay, so what we're going to do is we are going to use the triangle sum theorem and add all the angles together to find the missing angle. So we are going to use this triangle because we know that angle L is 70, we know that angle N is 90, and we want to find angle M. So we are going to say 70 plus 90 plus whatever the measure of angle M is equal to 180. Okay, so we are going to combine our like terms here. 70 plus 90 is going to give me 160, plus the measure of angle M is equal to 180. Then to get the measure of angle M by itself, we are going to have to subtract 160 once on each side of the equal sign. 160 minus 160, those are going to cancel because they add to 0, leaving us with a positive measure of angle M. And then 180 minus 160 is going to give us 20 degrees. So angle M is equal to 20 degrees. But we didn't want to find angle M, we wanted to find angle 1 or angle X. But since angle M and angle X correspond, then that means that angle 1 is also equal to 20 degrees.